Oracle's OCI Zero Trust Packet Routing, or ZPR as it's commonly known, is a modern network security model that's built directly into OCI. It applies zero trust principles at the packet level, and unlike traditional networking, ZPR doesn't assume internal traffic is safe. Instead, it enforces strict, policy-driven routing that blocks lateral movement and also isolates workloads. The result? A highly secure, microsegmented cloud environment that's ideal for protecting sensitive data and critical applications. In this demonstration, we will configure ZPR to protect the following architecture. Within this, we have a single virtual cloud network, or VCN, as it's more commonly known. Within this, there are 4 subnets. There is a single public subnet, which means it's accessible directly across the internet. This contains a jump server that we'll be using to perform administration activities. We then have a client subnet, a load balancer subnet, and a web server subnet that are all private subnets. Within this, the client PC should only have access to the load balancer, which in turn will provide access to a web application that's hosted on the 2 web servers. We'll walk through the process of configuring ZPR and the appropriate policies to ensure that each compute instance has the minimum amount of access to other instances within this virtual cloud network to prevent any potential security breaches or issues. Now, the first thing that we need to do is to create a security attribute namespace. To do this, within the OCI console, we go to Identity and Security, Zero Trust Packet Routing, then select Security Attribute Namespace. There is a default namespace that's available, however we'll create our own for the purposes of this demonstration. I'll call it Brendan ZPR, and once that's been saved, what we can then do is click into the namespace and create our security attributes that we will use to tag resources. I'm going to create a single attribute called role. And what we will do within this is include a predetermined list of values that resources can be tagged with. And what I've done is created values for each type of resource. So we've got client, jump server, web server, load balancer, and app VCN. So once we've created those list of security attributes, we can now look to create security policies. One thing to point out before we create any ZPR policy statements is the fact that ZPR doesn't replace security lists or network security groups. In order for traffic to be permitted, there must be a ZPR policy and a security list or NSG that also permits access on those specific ports. For this demonstration, we have 2 security lists. We have one associated with a public subnet that provides access from any public IP address to port 22 for SSH. This allows us the ability to SSH into the jump server. The 3 private subnets all have the following ingress rules on their security list, which provides access to port 22 for SSH traffic and also port 80 for HTTP traffic. Just to remind you, ZPR policies supplement security lists and NSGs rather than replacing them, so we need to ensure that security lists and NSGs are in place that permit traffic that is required. ZPR will provide an additional layer of protection upon this, controlling access further. The first policy that we'll create will be for the jump server. This will provide the ability for me to access the jump server using SSH across the internet and also provide the jump server with SSH access to the client machine. We'll use the manual policy builder for this, and we will write 2 policies, which I will just input into the manual builder. The first policy provides access from any public IP address to the jump server, and the second policy provides access from the jump server to the client endpoints on port 22. The second policy we create is for the client machine, and for this there is a single policy that will provide the client machine with the ability to connect to the load balancer that sits in front of the 2 web servers. So we can see client endpoints now available to connect to the load balancer on port 80. And finally, we will create a policy for the load balancer which provides access to the 2 web servers. Again, we will add a policy statement and then from this select the manual policy builder. And this provides access from the load balancer to the web service on port 80. The next thing we need to do is to add security attributes to the resources that we're looking to protect using ZPR policies. So we'll go into protected resources, and from this we will select the jump server compute instance. We'll then select the namespace that we created, the security attribute, which is role, and then the attribute value. In this specific case, the attribute value we would like to add is jump server, to define this as a jump server. We'll then select the load balancer, which is just displayed as a VNIC. Again, we'll choose the Brendan ZPR namespace role, and in this specific case, choose the load balancer security attribute. Once we've done this, the next thing that we can do is to select the two web servers that we have. And for these two web servers, again, we will select our Brendan ZPR namespace, the role security attribute, and the value that we'll assign to this is web server. We'll then select our client compute instance and assign the role of client to this. And then finally, we will add an attribute to the VCN itself. We will assign this the role of app VCN. The reason for assigning the attributes after we've created the policies is by default, once you apply an attribute to a resource, it will block all access to it if there isn't a ZPR policy that provides access, as I found out unfortunately. The final step is for us to test our ZPR configuration. And to do that, we'll initially attempt to connect to the jump server, which is available publicly across the internet using SSH. And there we go, we can see we can access that successfully. The next test that we will do is attempt to connect using HTTP to the load balancer IP address, which should fail because we don't have a policy that permits access to that. And there we go, we can see that that connection has failed. The next thing that we'll do is we'll attempt to SSH from the jump server to the client machine. And as you can recall, we do have a policy in place that permits that. Now we're on the client machine, we will attempt to connect to the load balancer. And as we can see, we get connected successfully and we're able to connect to both of the web servers that the load balancer is reverse proxying. We now attempt to connect to one of the web servers directly. And as you recall, we don't have a policy in place for that. So this should fail. So there we go. We can see our ZPR policy configuration has worked successfully. Thanks for watching.